So these two machines here are roughly the same age and they are identical in terms of what they can do. The control systems on each of these varies ever so slightly, but ultimately they do the same thing. Okay, I'm not going to go into speeds and feeds and all that stuff with you right now. We simply don't have the time. But just to say that we would calculate speeds and feeds on the lathe much the same way we do speeds and feeds like we do with the drilling, right? It's all based on the diameter of our part. Okay, so what do we need to do about the machine? So first of all, we have a pilot light, just exactly like we have on our saw over here. And so when you see that guy on, the machine is under power and it's ready to go. So if you walk up to the machine and there's a pilot light, of course, we've got our on-off switch, just like we have with that guy right there. Now this guy here also has a pilot light, but I think the light has burned out. I'll have to check that here in a minute. That last lathe down there is really old. It has none of that. And technically it shouldn't even be here. But anyway, we'll get to that one in turn. Okay, so we'll turn the machine on. We got power, so of course the machine doesn't kick on. The way we turn the spindle on, first of all, it's always a good idea to move the carriage assembly back a little ways, get it out of the way of the business end of the machine before you really do much of anything. That way if something goes, nothing can go wrong. You're not gonna hit something. This handle right here on the front is what turns our spindle on and off. Now the way this works is, on this machine you pull out, in whatever direction you push the handle, if I pull up on it, it's going to take the chuck and turn it in this direction, clockwise. If I take it out and push it down, it's going to turn our chuck counterclockwise. Now this is where it gets a little weird. On a lathe, our tools are stationary. If I put a drill in the tailstock here, my drill is stationary, it does not turn. My work is what's moving, right? So on our milling machines, our paradigm was what in terms of direction? Always clockwise, right? All the tools will always ever turn clockwise, right? Well, now the tools are stationary, so now I have to turn this guy what direction, you think?
Counterclockwise.
Counterclockwise, right? And so when you turn the machine on, always take a quick second, look at the chuck and make sure it's turning counterclockwise. If the tool is on this side of center, it has to turn counterclockwise in order to cut. If my tool is on the back side, I can now turn clockwise in order to cut, right? So I can actually do that if I need to. All right, but most of our work is done between you and the machine in terms of where the tool will rest. Okay. All right, so when I take this guy here, I pull out and down, we'll turn counterclockwise. On this machine, you push in and down to accomplish the same thing. Same manufacturer, 3 years apart. For whatever reason, they changed that. Okay. And of course, you're going to notice that the controls are slightly different as well. Okay, so I'll push it out and down, and my chuck turns on. If I want to stop it, I can pull this back to the neutral position. It will coast to a stop. If it's running and I want to stop it quickly, I will step on the foot brake, which notice that the pilot light went out. There's a set of brake shoes that expand just like the brake on our milling machines and stop the chuck instantly, right? Now when I release the brake, nothing happened. My lever is still down, but nothing's happened. And so that's a safety. So it doesn't automatically kick back on once I step on this is technically the emergency brake. Okay. So in order to start my chuck back up again, I must now return it to the neutral position. And when you do, you'll hear a clicking noise, relay resets. Now when I'm out and down, it's back on. Huh? Yes, it did. Oh, did it? Yeah, so the pilot light's giving current. This is the one that's actually on its way out. Okay, so anyway, so same for reverse. Working in another direction. That's fine. We just need to go in that direction. Okay. I should have kicked on the other one. I got to go work on the switches apparently. Okay, so that turns our chuck on and off as we need to. Our tool, now for you guys, the tool is already preset in the machine. I will say this is what's called a quick acting tool post. So to get the tool out, I simply move this lever counterclockwise and I can slide the tool off and drop it back into place. Because of the way it's arranged, the center of the tool comes right back to center. This tool is set up uniquely for this machine. I can't take this tool off and move it to any one of these other machines, even though they have the same tool post, because the center heights between all three machines is slightly different. Okay? So don't mix and match. Okay? People try to do that with varying results. If you're cutting and it seems like the finish looks really, really bad, a lot of times what happens is this guy will be loose and it allows the tool to kind of rattle around a little bit. Okay? Always take a second, just with the palm of your hand, just kind of give it a couple of quick wraps to tighten up this tool post. Okay? Make sure it's in there. So what this is designed for is I will have multiple tools, different styles of tools for different sort of things that are already preset to this machine's center height. And as I need them, I simply take one off, drop the other one on, and keep working. Whereas if I had an older style T-post, I would have to stop, reset that particular tool for center and do a bunch of other things, which is super time consuming. Okay? So we're using a piece of carbide in here. It's a profiling tool, which will work for what we want. So we're going to be using this tool, and we're going to be using our tail stock here to help us.